I'm Jakob. For those who don't know me, I'm originally from the mountain rescue team in Germany. That's like I got into contact highlining like with friends, and at some point we asked ourselves, what actually is if you would want to do a helicopter rescue with off a highline basically. And we started basically doing our own project in order to investigate this. It's been in its third year now. So the main three people are me, Aaron, and Lucas. And we had, of course, a lot of help, a ton of support from the Martin Flugrettung in Austria, also the Bergwacht now, and also Red Slacklines. Next slide, please.
Yeah.
Okay. So the first question is why would you even want this? Why would you even attempt to rescue someone with a helicopter off a highline? So if you do a highline in alpine terrain, you of course have anchors that are like not easily accessible. Sometimes you have to rappel or have to do something else to get to the anchor. So terrestrial rescue, even if someone on site is very good at doing that, is still limited to, for example, rappelling or like getting in the patient to one of the anchors. And then you're still in alpine terrain, so you probably still want a helicopter to get your patient to the hospital, especially if the medical side is not looking too bright. And all of this requires long periods of hanging in a harness, which, because of the medical condition that creates, is bad for patient outcome. So a direct rescue off the highline can just drastically improve the medical diagnosis and prognosis. And that's why we initially started this. Next slide, please. So of course, we're not the first. There have been some French guys doing that in the like that also puts some stuff on Facebook. We tried to contact them multiple times. They never replied really. And you see how seriously they take safety. If you look at the guy on the highline that is not even wearing a helmet. And I mean, this was a planned thingy, so it was not an accident, but okay, sure. And then also like, how did we get into contact with Heli Austria and the Martin Flugrettung? They had themselves a highline rescue that was in 2012. Next slide, please. Okay, so, but what is the target? Like, where would we need to go in order to get this to a usable state? And of course, you have to look into the certification of helicopter procedures. So HEMS is Helicopter Emergency Medical Service. HAC is Helicopter External Cargo. So that's basically you're flying a rescue mission with someone on a long line or on a rescue hoist. And the regulation says that the people need to be equipped, trained, checked, and briefed. Okay, sure. You need to have an SOP, which stands for Standard Operating Procedure. And that has to follow a risk assessment. So you cannot just say, oh, this is going to work and then do it. And then, of course, your personnel has to be experienced. It has to be trained, and it has to like check if they still know what they're doing. And they give a bit more information about the risk assessment. So the operator shall assess, mitigate, and minimize the risk. So you have to know the risk, like how dangerous are certain steps. And you have to describe the mitigation if you ever put one in. Next slide, please. So now we know basically where we want to go.
One quick question about the last slide, actually, from me. Is this 2012 incident, was that a real life emergency or was that a training?
That was a real life emergency.
Okay, and they rescued someone with the helicopter from the highline?
Yeah, but in that case, they cut the highline. Like they cut the line, not the leash.
Okay. Thank you.
Sure. Okay, so of course we are not helicopter operators ourselves, but we can basically help them develop a standard operating procedure. So what can we help with? First point is we can help with the risk assessment. I mean, most of the helicopter operators have never even seen a highline, so what is that? How are the forces looking? What happens? What is the backup? What is even there on site? Then we can look at strategies for risk mitigation for flight training, because we know how to rig a highline and how to make it more sturdy. We can show the main risks and mitigation, and we can do that in like lab experiments. And we can help develop like a proxy for a procedure, like a proposal. And of course, the highliners on site could help in a rescue. So how would you do that? How would you spread this information? And of course, if you are a helicopter operator now that wants to train this, you need someone to rig a highline for you. So we could help in basically just doing that. Next slide, please. That's like the long-term goal. So what have we done so far? So for the risk assessment and mitigation, we started with the functional hazard analysis, which is like standard in like air certification. We started with that in like German language only, because we worked with the Austria and they only spoke German. And it was with a long line. So that's basically like, you can think of that like a climbing rope that you attach to the fuselage of the helicopter, and you are on the line, and not a hoist, which would go up and down and has a hoist operator. And then we managed to fly this procedure with them. We did, I think, roughly 30 flights in a risk mitigated setting. So we took our functional hazard analysis, checked what can we mitigate, and then we developed the training procedure for that. Then we presented this at the IICAR, which is like the big conference where all the helicopter external cargo operators meet and the safety guys. And we also presented at the last ISA meeting. And while we're doing, basically while we are at IICAR 2023, the Bergwacht Bayern, which is basically the mountain rescue team of Bavaria and Germany, said, yeah, but, or a lot of people in the meeting said, okay, but most crews want hoists, and hoists have like 4mm steel cables that are not smooth, like they are pretty rough on the outside. And we should kind of try this next, like in a lab. But I included QR code. I didn't want to show the video again, but you can just get it from the videos on YouTube. You can see the whole rescue procedure and how like it takes minutes, literally. So you can get your patient off your highline and onto the way into the hospital in minutes. Of course, this is a training setting and everyone is prepared, but just to show that it really saves a lot of time. Next slide, please. Okay, so where are we going from this? So the long line rescue worked in a training, so that's pretty good, but and all the risks could be mitigated, but most people don't really use or want to use long lines anymore. Most helicopter crews transition to hoists. And we did an experiment with the Bergwacht that showed hoist cable contact with the highline webbing, and even a few meters of movement of hoist cable between hoist cable and highline in contact was enough to cut the highline webbing, which would be catastrophic. But that's what they want to use, and they will not, like helicopters will not refrain from using hoists in their rescues. But it is dangerous. That is what we showed at last ISA meeting. If you want to see the video, just pull up the thing from last year. So we ended up, okay, we need a way of mitigating the contact between the hoist cable and the highline. And that mitigation has to be within whatever the crews can handle. So if you tell them now you need to open a laptop and do a calculation, they will just immediately be not following you anymore. So they have to have the usual tools. And as soon as you modify anything, because everything that's bolted to the helicopter is fundamentally different in certification than everything that you clip into something that's bolted on the helicopter. So, for example, you can clip anything into stuff at the helicopter that's UIAA certified, but as soon as you have to change a bolt or have to do anything different, like that structurally attached to the helicopter, it needs to go through a whole certification cycle of airplane certification. So that's what we want to avoid. Next slide, please. Okay, so what have we done since 2024? We did, in the lab, we did a test of a climbing rope versus a highline webbing because they all have a climbing rope on board. And the softer contact could be beneficial. Then we presented these experiments at IICAR 2024 and got some feedback from the operators. And then we sent the webbing that we tested in contact with a climbing rope back to ISA in Bern, and they pulled it basically to see how much damage actually occurred. We translated all of our documents to English. Thanks, Michael, who helped with this like a lot. And now we have a public website that also has versioning, so you can see what we changed in the procedures, whatever. And you can hopefully soon, right now we don't have enough storage, but you can get even our raw data. So you can just pull it yourself and do all the calculation yourself. Hopefully you do, because then someone else would calculate it independently of us, but just it has to be open. And we were planning and preparing experiments with a rescue hoist, but had some problems, like mainly time restrictions. So we pushed that to the next year. So, but that's what happened last year. Okay, next slide, please. So for the test, climbing rope versus highline. So we previously, for the hoist cable versus line, we had a 50-meter highline that we rigged into, was basically a testing ground at Bergwacht. We this time shortened it a bit to make it more like easier to handle with just 2 people and not like 5. So it's 6.8 meters of length. We had a tension that was in the range of 3 to 4 kilonewton. We had a 70 kilogram patient that you can see that is these gym weights like down below on the, like right on the map. The patient was fixed to being like 20% of the length from one of the anchors from the side. We had a 100 kilogram flight rescue, which is, you might think it's a lot, but they sometimes are a bit chunky. The rope we used was a Edward Swift. It was not new, it was rather like towards the end of its life, but we wanted it to be rougher. And we did 25 cycles at 2 meters of change, like up, 2 meter down. So in total, it was like 100 meters. So that's a lot of contact in friction. And we adjusted the angles and the forces so they were the same as in our previous experiment with the hoist cable, where the hoist cable was able to cut the webbing within a few meters of movement. And this time we didn't break a single webbing in test. We could do 100 meters of moving contact with the same forces, and none of them broke. Next slide, please. That's a zoom in of like the contact patch. You see that the webbing is like folding a bit because we didn't almost not see this with the hoist cable. Hoist cable is like 4 millimeter, a bit more. But the climbing rope already like is softer and basically gets it to fold. We always try to have the weak side of the webbing where the contact with the rope is. Then I forgot my leash ring, so we had to use a replacement with the largest carabiner we found. The hoist we used an electric hoist because you don't want to pull the 100 meters of 70 kilogram person by hand. So we did that with an electric hoist, but it has the same speed as the H145 hoist. The Bergwacht has like a ton of things that they use for training that are like rated to the helicopters. As said, it was a used climbing rope. We used the same section of the climbing rope on all of these experiments. So this was really, really used in the end, but it looked like I would still go climbing with that. Like it didn't, like the climbing rope had no visible damage or anything. And we tested 3 different lines. We tried to do a Dyneema, PA, and PS, and all of them were new. because we want like fresh samples. Next slide, please. Okay. Interestingly, the Bergwacht also had a microscope. So after that, I spent probably too much hours microscoping the thing. You see, this is the Dyneema, and it was white. So when it was new, it was almost see-through, and this like a backlight microscopy. And you see that it takes quite a lot of damage. You can see that some of the bundles are like way more transparent than they were before, so they probably like got pretty hot. You also see the frizzle, and if you look at the zoomed in picture, you see that it really looks damaged, but not too bad. Like consider that it was 100 meters of contact of like two like heavy weights creating a lot of contact pressure. All of the webbings had some friction damage, but the rope being like flattening a bit and being like the 8 millimeters instead of like 4, spread it already over a larger area. And like this was just from what we observed while doing the experiment. It was during the first few meters of contact that we created a lot of damage, and then it would basically level off. Next slide, please.
Can you say again what the tension of the webbing was when you tested?
It was 3 point something to 4.2 kilonewtons.
Thank you.
Sure. Then we did, because we wanted to go to, or we were invited to IICAR 2024. They actually asked us if you want to give an update because they had a lot of interest. So we did a break strength test at the Bergwacht, and just for 2 of the webbings, which they, I mean, it's lower than the spec, but it's still pretty good. And then we presented the joint result of Hoist cable versus Highline and climbing rope versus Highline at the IICAR. And this was not done by me. I couldn't go. It was in Greece, but someone from the Bergwacht did it. Next slide, please. Okay, but we had like way more samples, so we sent the rest of them to the ISA, and they tested them with the usual problems. So the 19 millimeter Dyneema you see here in the machine on the right. You also see our, like the tape basically marks where the damage is, like it's right next to that, the black spot, and with our numbering. And we also included reference strips basically of the same batch of material in order to have at least one reference. But we maxed out all the, like as much tests that we could do, so we didn't have much material left. Next slide, please. And here you see the results. Green always is the reference, and you see basically the numbering, then you see the material, you see the breaking strength, where it was tested, and you see difference to spec. The difference to spec, if it's positive, means it's above spec. If it's below, if it's minus, then it's below. And we saw that, like for the Dyneema, which we kind of expected, that's why we did more experience with Dyneema. The reduction is the highest. It's up to 36%. But if you look at the breaking strength that's still left, and you have to think about, like, this would be someone fell into the Highline, is a patient now, and like he's not gonna like highline while he waits for the helicopter. So he's about to be in a helicopter rescue scenario. So it's a static setting. So in any case, it's way better than a line being cut by the contact. So this would be the helicopter comes, picks you up, and they would need to go over this and even first create enough damage to basically damage the webbing.
What was the value of the dynamite in total? So we only see the differences now. What was the average breaking strength of these pieces?
I didn't calculate the average. You can see the breaking strength in the third column.
Oh,
yeah.
I didn't see. Sorry. Yes.
Yeah,
sorry.
no,
my mistake.
It's fine. So I didn't calculate. I thought statistics on like 6 samples. Let's not get ahead of ourselves. And what we also saw is if you look at the values of that was tested at Bergwacht, they were higher. Like it's just a few values, but what they did in order to anchor them like in their machine is they had like rings, like metal rings that were like 60 centimeters in diameter, and they wrapped like multiple times around these in order to create enough friction. So they had a very, very gentle induction of load into these. It might be interesting or to investigate if that actually made a difference if for testing. But like these are like way too few samples in order to get anything from statistics. What I just wanted to show here is like there is basically a reduction in strength. It was a very, very bad scenario. I mean, 100 meters of contact is a lot. Like just think about how like it took 20 minutes just to like do all the movement. So this is just the worst of the worst case. And even then you would still have left for Dyneema, you would still have left like 20 kilonewtons of braking strength.
Quick question, where did the breaks happen? Did they break at the weakening or did they break in the anchors?
No, they broke in the weakening.
Thank you.
Sure. Could you go to the next slide, please? Okay, so what do we make from this? The climbing rope seems to be way less critical than the hoist contact. The hoist cable cut the webbing, the climbing rope did not, even though we really, really tried. Which is good because the climbing rope and the rappel device is included in every cruise equipment. All of them that go into the mountains have this on board. They wouldn't need to pick it up. They know how this works. It's not something that they would see like, why do you want this new technology here? Like, no, this is something you've seen for long enough. They could still exit from the, like, one of the main advantages of a hoist is you can just fly there, look at the scene, open your door, get into the hoist, go down. They can still do that. They can still exit in like mid-flight. They can just clip in like the short part of the rope and then rappel on the rope. If they would land, they cannot, like if they now extend, like rappel down a bit, they would need to do a hoist cable landing. They cannot hoist the crew back up into the cabin, but that's not the big deal. There is no modification to hoist or helicopter necessary because it's just attaching stuff to the rescue hoist hook. So no certification, and everything that's UIAA certified is by the EASA is allowed to be used in that way. So that's good. It's like basically no real roadblocks there. And that basically allows to transfer our previous experience with the long line, which is very similar, to hoist rescues, and we could mitigate like the biggest threat basically that we saw. Next slide, please. Okay, so again, just to stress this, we translated everything into English. We also had a bit of contact with some American and Canada-based helicopter operators that were very interested in the documents. We probably, like on the webpage that you see in the QR code, we have all of our simulation models that we did mechanical simulations before, all of our documents describing these simulations, all of our planning, all of our presentations on this open access website. I will try to make the videos and photos available as soon as I can figure out how to get more storage space. And it's automatically versioned because we are using GitHub, so you can basically go back in time and see what we changed and when and what was the reasoning for that. Again, thanks, Michael, for helping with the translation into English. He contacted me after last IICAR meeting and was like, hey, can I help? Next slide, please. Okay, then we wanted to plan for 2025, but we had some uncertainties. Mainly, Aaron is in med school. He's in his final year, so he is having exams, and he has a PhD that he has to finish. Lucas right now is traveling South America, so he is basically not reachable for us. And I moved to Tennessee for a postdoc, so we had a bit of difficulties on our side. And like to add to this, Heli Austria had internal discussions. They only recently bought a helicopter with a hoist. So they were like, we are still in the like testing phase, and not all of our flight rescue personnel does know how all of this works, and had some technical uncertainties that they could not figure out. Next slide, please. So we basically planned to try this, but they also said they want to do this with us, but we could not get it to work in the 2025 timeframe at least. Next year is looking like way better. So we hope to do this in 2026, and like just as a general warning, please, like the red line at the bottom, please, at the current thing, do not rely on helicopter rescue and highlining. I think this should be clear to everyone, but I just wanted to stress it because it's really important. This is in the project phase. We are working on it, and it will still need to be adapted, and people would need experience with it, but we hope we can get there sometime in the future. Anyways, even though I preparing this talk thought, oh, we haven't done anything, we have done quite some progress in the last year, especially the tests with the contact with the rope. There was quite some international interest, but still, please, if you ever talk to a helicopter company or a rescue guy, try to spread the information. It always helps. We try to make everything as easily accessible as possible, so people don't have to write an email or get like maybe call me, and that is already like too much to ask. So they can just, without us noticing, go to the website and download whatever. And yeah, I said we hope to do a Hoist-based rescue in 2026, and then also be present at IICAR in order to present the results. Next slide, please. Yeah, if you can contact any of us, like either me or Aaron or Lucas, doesn't matter, or you can contact Tom and he will just forward that. It's all fine. If you ever think you would want to know someone who already did this, we can connect you to some helicopter crews that have trained this with us, so they at least have some experience. But yeah, so please don't rely on this working in reality and in a stressful scenario, because for now it's still experimental. Next slide, please. Yeah, and with that, I'm done. And I hope there is some questions or some discussion. Sorry for the technical difficulties. I hope it was still fine.
Well, thank you so much, Jakob. Are there any questions? I have a question. What are the other two slides? Am I allowed to skip forward?
Yeah, sure. There is one with the references, I think, and then I might have exported some backup. Yeah, I had some backup slides. There's like 20 more slides just for in case someone has questions about specifics.
Great.
And of course, I will always, or like maybe not today, but soon we'll upload this to our document thingy, so everyone can download it and reuse it for whatever.
And I believe we will upload the slides and the videos as far as the speakers allow it to our website as well.
Okay, cool.
Well,
any questions?
Yeah, any questions? Any other questions? Well, thank you for this very informative talk. I was very interested. Let's thank Jakob with our emojis, and we go on to the next talk. Thank you, Jakob. Oh, wait, sorry. One question by Samar, I think.
Yeah, go for it.
You can just unmute.
Sorry, I was looking for the emoji, but good job. Thank you.
Okay.
Cheers, guys.
Okay, then, oh, I am stopping to share, of course. And Augustin will talk to us next. What? Oh, Laurent has a question in the chat. Why did you choose climbing rope and not access rescue semi-static ropes around 10-ish millimeters?
Okay, so it could also be done. We were just like the things or our thoughts were it probably is better if it's textile, so not steel. And we were thinking, what is something that they always have on board and that you could basically exit the cabin and then rappel? That was the main idea. There has been some experience in Norway where they often have very inaccessible rescues where they use the full 200 meters of cable that's in the winch, in the hoist, plus 90 meters of climbing rope. And they were basically saying that it works pretty well with the climbing rope with a little bit of dynamic that you have in the climbing rope and like in a static setting, basically. And it really helps when they fly these very, very extended scenarios. It could still be interesting to look at that. The thing is also like for testing, it was very easy to have a piece of climbing rope, but not necessarily a piece of certified static rope that you can use in a helicopter. And since climbing rope has the UIAA certification, you can just use them on helicopters. Like that's no problem. That was basically the reasoning. But yeah, it's not fixed. It could still be changed whenever a crew says, for example, they want to use something else. We need to do some experiments, but still, that would not be a roadblock. Like, yeah, sure.
Then I have one more question about the abrasion, because now you tested like the rope going along the webbing, but what the other way around? So if you're not having a horizontal movement, but like movement along the line, that like the rope might get damaged by the edge of a high line. Did you consider this already? Or?
No, we have not. So it would be, I agree, it would be a very interesting thing, especially if like the edge of the webbing is like a bit rough and you would now think, oh, I slide like 20 meters to one side. That could be a problem. We have not tested that in our flight experiments. Most of the time, like the vertical movement, because it's way harder to control, was way more critical than sideways. The helicopters most of the time were very, very precise in positioning themselves, like with respect to the line length, basically. But like they often overflew the line and basically pulled the rescuer into the line. That's the scenario we looked at. And like for the rescuer, if they touch the patient begins like bouncing a bit, and that creates like the friction. So we did not look at that scenario. I do agree it would be interesting. If someone has an idea how to test that in a like reproducible manner and has some time and wants to help, sure, please contact us. Yeah.
I think we excluded this scenario in our first tests at the Bergwacht because it's super hard to even imagine a situation where the webbing cuts all the time on the same spot on the rope. So I think that was the main reasoning to not really test this kind of scenario.
Yeah, but I do agree. It could, in theory,
sure.
like if you're talking about worst case, it could happen. Yeah. But yeah, we have excluded that for now. Yeah. But if you have time and want to do this, please contact us.
One more question by Simon.
Yeah, sorry, I had to activate my micro. We've done some rescue tests also with the winch from the Bundespolizei in Baden-Württemberg, not Highline related, but they told us that their standard bailing scenario is that they pull the winch up and also lift the helicopter. So the speeds at which you might have some rubbing might be a lot faster than what the winch itself produces.
That's not going to work. Like if they do that in a highline rescue, they will get entangled. So they have to decide, and we discussed this in length with Austrian guys. They have to approach the line. They have to decide from which side they want to do the rescue, and that is mainly related to can the helicopter bail in that direction. They cannot just, if they are like way above, like if the highline is here and the helicopter basically flew, it came from this side, so your rescuer is dangling behind, you're flying like overshooting the line. As soon as you do that, you cannot pull up. You have to go back. And that is kind of critical, that you have someone in the cabin that is looking like that straight down at the line and telling the pilot, oh, you are too far forward, like come back a meter or like whatever. And if they needed to bail, they would basically just tilt the helicopter backward, like get away from the line, then turn around and do a dive with the person still attached to the long line. So for the hoist, it will kind of be the same. They can winch them up like as soon as they are no longer in contact with the line. But as long as you're in contact with the line, you cannot just pull them up. That doesn't work. So that they should not be trigger happy in that scenario.
Well, thank you for all the interest and the questions. We have one more comment that I'm just going to read out, but if there's more interest in discussions with Jakob, please send him an email. Send us an email if you need to get in contact with him. Leighton suggests to put a sleep padding around the highline, close to the patient maybe, can be considered as well by Jakob. Thank you, Jakob.